Chapter 5 is all about polynomial and rational functions. What we're primarily going to focus on is finding the important points on their graphs and how to graph them. So section 5.1 is an introduction to polynomial functions. So a great place to start is with a formal definition. So a polynomial function of degree n is defined by f of x equals a sub n, x to the n, a sub n to the 1, x sub n to the 1, and so on and so forth. And last we have a sub naught, which is our constant. All these a sub n's, these are our coefficients. And a sub n through a sub 1 are all real numbers, and our exponents are all whole numbers. The graph of every polynomial is continuous. That means that I can draw it without picking up my pencil. So let's determine which of the following are polynomial functions. For those that are not, state why. I want us to rewrite each polynomial in standard form if it is not already. We're going to identify our leading term, which is the one in front, our constant term, which is the one that's just a number, and determine the degree of our polynomial. So let's take a look at polynomial A. I have p of x equals 5x cubed minus 1/4 x squared minus 9. This is indeed a polynomial. Its leading term is 5x cubed. Notice when I say leading term, we're talking about the entire term, not just its leading coefficient. So we've got our leading term is 5x cubed. Our constant is -9. And our degree is 3. Let's take a look at, and it's already written in standard form because it goes from largest degree to smallest degree. Let's switch colors and look at problem B. I've got x plus 2 minus 3/4 x is my function. Well, this is a polynomial, but we must rewrite it in constant form, in standard form. And it is a polynomial, like I said. Its leading term, I'm just going to write leading. Its leading term is -3x to the 4th, and its constant is 2. This is actually a degree 4 polynomial. Moving on to C. I have g of x equals the square root of x. So remember that this also means x to the 1/2. Because my exponent is not a whole number, this is not a function. All right, let's take a look at problem D. H of x equals x squared minus h over x cubed minus h. This is a rational function, which we're going to learn about in sections 4.4 and 4.5. But it does not take the correct form of a polynomial, so this is also not a function. It's mainly not a function because it's not continuous, which we'll talk more about in sections 4.5.4 to 5.5. So let's take a look at E. G of x equals 8. This is a constant function, so it is still an example of a polynomial. Its graph would just be a horizontal line. Its leading term is 8. Its coefficient is 8. Its constant is 8. And its degree is going to be 0. Last but not least, F. I have h of x equals -2x cubed times x minus 1 squared. Well, this is a polynomial, but it's definitely not in standard form. We're going to have to FOIL this out. X minus 1 squared, that gives me x minus 2x plus 1, x squared minus 2x plus 1. And then I go ahead and multiply and distribute in this -2x cubed. That gives me -2x to the 5th plus 4x to the fourth minus 2x cubed. So now I can say this is definitely a polynomial whose leading term is negative 2x to the fifth. Its constant is 0 because there is no direct constant, and its degree is 5.